Now, till now we have seen that short circuit current and short circuit MVA value depend upon percentage reactance, or we can tell per unit reactance, right? Short circuit MVA value is nothing but rated MVA into 100 by percentage reactance. So, short circuit current and MVA value depend upon percentage reactance, right? So, if the per unit reactance increases or percentage reactance increases, it will reduce short circuit value, right? So, if we'll write one by one each and every point. If percentage reactance increases, then then short circuit current and short circuit MVA value will be smaller, right? So for that we need reactor, okay, which will increase the percentage reactance value and limit your short circuit. Okay, so for this we need reactors that limit the short circuit current or short circuit to a safe value. Okay, now what are reactors? What are reactors? It is a coil which have higher reactance value as compared to its resistance to protect equipment and whatever the installation is there in power system. Okay, it is a coil having high reactance value reactance value as compared to its resistance used to protect equipments and installation. Now, for this purpose, we use series reactor. Okay, now suppose this is generator and the percentage reactance of this generator is 10%. Okay, is 10%. Right now we are not using any reactor. Okay, so what will be the short circuit MVA value? That will be equal to rated MVA right, into 100 by percent x. So percent x is 10, so this will be 10%. Okay. Now the circuit breaker which we require depend upon this short circuit MVA value, right? The circuit breaker which we require depend upon this short circuit MVA value. If the short circuit MVA value is higher, the rating of the circuit breaker will be higher, right? If short circuit MVA value is higher, is higher, the rating of required the required rating of circuit breaker, I'm sorry, the required rating of circuit breaker will be will be higher, right? Now suppose we use here a reactor whose reactance value is given as 5% and fault occur at this point, then short circuit MVA will be equal to rated MVA, that will be same, right? Rated MVA into 100 by percentage reactance. So total percentage reactance will be 10 plus 5, that is 15. Okay. Now this percentage reactance increases, right? So because of that, the short circuit MVA value will decrease. If the short circuit MVA value will decrease, the required rating of circuit breaker will be lesser, right? The required rating of circuit breaker will be less, right? So if you are not using any reactor at that time, your reactance value will be same as the reactance value of the generator, and because of that you will get some short circuit MVA. According to this short circuit MVA, we need to put circuit breaker of required rating according to this short circuit MVA, right? Now if we implement a series reactor with generator, okay, whose reactance value is given as 5%, so total reactance value will become 15%. And what about short circuit MVA? Short circuit MVA is nothing but rated MVA into 100 by percentage reactance. So the total percentage reactance is 15%. If this value increases, if the reactance value increase, your short circuit MVA value will decrease. Okay, if your short circuit MVA value decreases, the required rating of circuit breaker will be less as compared to this, right? So with the use of series reactor, so series reactor thus reduce short circuit kVA of circuit breaker, right, which is installed to protect equipments and installation. Okay, now we also use shunt reactor. Okay, so we use shunt reactor to absorb reactive power. Okay, but our main objective is to protect your system with reactors. Okay, what is the purpose of reactor? It is used to protect your equipments and installation what is there in your power system network. Okay, so if anyone asks you how you use reactor in series or shunt, then your answer will be in series, because shunt reactor we use for absorbing reactive power. This is not the main objective of your reactor. Okay, this is not the main objective of your reactor. Now, what we saw in series reactor, okay, a reactance of series reactor will be higher as compared to its resistance. Okay, so that so that network efficiency will not get reduced. Why we are using a reactor which have high reactance value and low resistance value? See, if resistance value is high, then I square R loss will increase, right? If I square R loss will increase, this will reduce your system efficiency. This will reduce system efficiency. Okay, now next is how we use reactor. So it depends upon location of reactor. Okay, so depending upon location, depending on location, we have generator reactor, we have feeder reactor, and we have bus bar reactor. Okay, in bus bar reactor, we have two types. One is depend upon connection, that is ring system, and another is tie bar system. Okay, so what is generator reactor? If reactor is connected to generating side, first is generator reactor. So if reactor is connected to generating side, this is the common bus bar and this is load. Okay, feeder. So this is common bus bar So if reactor is connected to generating side, that we call as generator reactor. Okay. Next is feeder reactor. If reactor is connected to feeder side, if reactor is connected to feeder side, that reactor we call as feeder reactor. Okay. And third is, suppose we have two generator here, and if we connect reactor to a common bus bar between both the generator, that reactor is called as bus bar reactor. And this bus bar reactor is of ring system. Okay. And if you connect reactor between generator and common bus bar, like this, and this should be given to feeders directly from the generator, then this reactor is called tie bar system. Okay, or tie bar bus bar reactor. In this, the reactor are connected to the tie line. Okay. Now, see, to protect reactor from saturation, to protect reactor from saturation, the core of the reactor are replaced by coils or standard copper bars. Okay, because if you use any core, that will get saturated. Okay. Next is to calculate rated interrupting MVA capacity of circuit breaker. Okay, at which MVA values your circuit breaker will get interrupt. So that can be calculated as root 3 times of line voltage, rated line voltage, into interrupting current. Okay, or interrupting line current. Okay. Next is how to calculate short circuit MVA of a circuit breaker. So to calculate this, we need pre-fault line voltage. Okay, at the voltage after which the fault occur. Okay, that is called pre-fault line voltage. So we need to multiply pre-fault line voltage in kV into short circuit current in kiloampere. Okay, so that will be calculated as root 3 time of pre-fault line voltage into short circuit current. And next is, if these value, if the voltage and current value is in per unit, if voltage and current value is in per unit, then short circuit MVA of circuit breaker will be given as pre-fault voltage into short circuit current into MVA base. Okay, because see, if these are in per unit, this is what VA, right? This is uh, this is VA rating in per unit. Okay, this is VA rating in per unit. So if you want to convert your per unit into actual value, you need to multiply with the base value, right? So you need to multiply this with MVA base value so that you will get short circuit MVA of circuit breaker.